Good afternoon, everyone. I hope you all are doing well and are excited as I am for today's session. My name is Ashutosh Sabu, and I have the pleasure of being your moderator for this highly anticipated edTalk. Today, we are driving into a topic that is crucial in today's tech landscape, getting started with Google Cloud Platform, GCP. In just a moment, we'll hear from our esteemed speaker, Naveen Shahi, a cloud solutions architect and GCP expert with over 24 years of experience in the IT industry. Naveen has worked with top tier companies like Oracle, IBM, Morgan Stanley, and brings a wealth of knowledge and practical insights into cloud technologies. What makes today's session more exciting is that it's not just about learning, it's about taking actionable steps toward mastering cloud computing. Naveen will cover everything from setting up GCP account and navigating to the console to deploying applications and exploring key services like compute engine and cloud storage. You will also learn about real world use cases, best practices for security and cost management strategies. Here's a special incentive for you all. And here's a special incentive for you all. If you stay with us till the end, you will have a chance to win a rupees 1000 Amazon voucher each. So make sure you stick around for the entire session. Without further ado, let's get started. Please help me in joining. Please join me in welcoming Naveen. Naveen, the floor is all yours.
Thanks, Abhishek. First of all, I welcome you all to this session. Um, this is regarding Google Cloud services, and just to keep this thing realistic. Basically, what we are going to talk about is not 30,000 feet view and not even very low view, but basically there are essentially 200 plus Google services, right? And what I want to cover here is a pretty high level, take you from an architectural point of view. As an architect, what I have seen through my career of 24 years, how this thing has transitioned. So let's get started. Um, just give me a minute while I share my screen.
Welcome, Naveen.
Are you guys able to see my screen?
Yes, we are able to see your screen.
Okay. So what I want to do is let's transport ourselves back and do a time travel, right? When actually I was, starting my career in 2000, right? And that point in time, I just want to tell you that, things were not as easy as it seems today. Uh, I mean, based on my experience, I can tell I belong to a generation where, I have seen days where there was no internet, there was no mobile, and there was no cloud, right? And I belong to a generation where I've seen the shift from where basically now kids are born with mobile, born with internet, and there's a huge difference. We are consuming data like anything, right? And so when we talk about Google Cloud, right? Let's first assume that let's start playing a role, right? We all are a cloud, architect, and let's take a fictitious case where basically we are a cloud. Just a minute. So basically, let's assume that we are cloud architect for foo.com, right? Which is an internet application. It's a very simple application. It's a static application. So what is the first thing that you need? We want it to be accessible across the internet to the user, right? Now, this is a very simple case. Now, what do we need over here is a web server. So in 2000, when I started, basically we used to have all these very simple websites, uh, pretty much static content. Contact us. This is my phone number. You can come visit us, take orders, stuff like that, right? Um, and then basically, even at those times, I mean, when you open up the browser, right? How would you go to foo.com, and from there basically what the concept that came was basically the DNS server, right? So DNS server is something that you know you type foo.com on internet, every device has a unique IP address, right? Which they use to uh, communicate with each other. And that registry is maintained in something called DNS servers. You type foo.com, you get an IP address that client basically can now talk to your web server. Now that's very simple for an application, but suppose this foo.com, and let's take, I mean, this foo.com you can assume can be a food delivery service, it can be a Zomato, or uh, uh, basically transportation booking service, cab drive, anything, right? But how these applications have evolved over a period of time, right? Let's just focus on that. So basically, moving on from a very simple a static page application foo.com, let's say now that we have got some traction from 100 customers, we are going around 1000 customers, and now we need some business logic. We need sign up, we need to maintain user data, we need to maintain reservation, stuff like that, right? So for those kind of logic, we definitely need application server, right? Once we have the application server, um, and application server is there to handle your all your backend logic, authentication, and stuff like that. What's the next thing you need? You need a database, right? And I'm just telling you a perspective. Just remember, when I start talking about cloud, right? Before cloud, this is what used to happen. And once you get this puzzle right and all these pieces fit in, then you would know that, irrespective of Google Cloud or AWS or Microsoft Azure, right? How these components, why do these components exist within each of these, service providers, right? So it will be very easy for you. So it's just try to get this thing very formed up in your mind, this whole architecture, right? And everything will start fitting in once we start delving into the cloud. Now then comes the database, right? Now every modern application leverages one or more database to store information. That's pretty obvious. Now databases basically come into two flavors. One is a relational database, one is non-relational database. And guys, one thing is that if things are clear so far, right? Can you guys give me some sort of response, like thumbs up, move ahead? Any questions so far? Thank you. So I think we are good to go. Um, so relational database and non-relational database. Now from here, just a minute. Now basically relational database, we use it where we need ACID kind of transactional integrity. Non-relational database we need for OLAP, where we need a lot of analysis. This is the database which needs to scale to a huge level, right? Relational database is more like OLT, right? Now suppose in the next version of this, right? Basically, this foo.com has become more popular. It needs to support more number of users. How do you scale it up? And then comes the next level of challenge, that basically first of all you need to scale up your web server and your application server, right? Now scaling can be done in two ways. I mean, either it could be a horizontal scale or a vertical scale. um, and from web server, suppose we add one more web server, we add more tier 2 application servers, and this typically we know in industry called like horizontal scaling. We can also do vertical scaling to support more users. But vertical scaling obviously has an upper limit, right? You can just add so much CPU and memory, but horizontal scaling, basically you can just keep adding, servers like, commodity, right? And that's very easy to do. So so a question, right? Horizontal and vertical scaling, basically we'll just take a pit stop, and let's reflect back on it. If you ever have tried scaling an application vertically up or down, horizontally up or down, and some of the cases. So this is the question that you need to park. If you have some response, I would definitely love to have them on those comments. Moving on. Now the challenge that comes is that as soon as you have more than one web server, right? Now you have two IP addresses, right? And you know, internet traffic, a user that is trying to access your application from the browser, which IP address does it need to go to, right? So this is where the concept of load balancer comes in. So this load balancer in front of the web server basically is the external load balancer, because this is externally open to the internet traffic. And then we have another load balancer that comes in between web server and application server, because now we also have multiplicity of application servers, right? So this also needs to be load balanced. So the one that is outside is called basically outside load balancer, and the one basically that is inside is called internal load balancer. Good so far, guys? Thumbs up. Any questions? Thank you. Moving on. And we need to move this part because I think my whole goal is to spend very little time on this, but spend more time on how Google cloud components actually fit in here, right? So once you have this, again, I'll keep reiterating that once this is done, right, you guys will have a very easy time just cutting through any cloud service offerings, right? Because it will start making sense, because you'll have this story to glue it, right? That's why we are spending a little bit of time here. Now let's focus our attention on the database side. Okay. Now relational database, right? We know what all ACID transaction is: transaction processing, structured data. Basically, it's all collection of tables. These tables basically have primary keys. There are multiple tables which are related through secondary keys, right? So they are all related, but that's why they have all the relationship. That's why effectively it's called relational database, right? Plain simple. Whereas non-relational databases, right? They have dynamic schema, right? They don't have any structure. Very ideal for rapid application development. Highly scalable, um, and popular toast to the town DB nowadays, right? So, and most of the NoSQL databases can scale horizontally. Okay. Uh, so again, like let's leave it this question that during your endeavor or technical work, I mean, was there any point where you had to make this decision between relational and non-relational database, and what were the what were your considerations choosing one versus the other, right? um, what kind of relational and non-relational databases have you worked? Just reflect on it. If you have some comments on it, happy to share with others as well. Moving on. Now, once you have this entire architecture in place, right, what also starts happening is that over a period of time, if you have analytics on, you'd very quickly come to know that every time application server is hitting relational database, some data is is repeatedly called. I mean, 90% times that data is fed repeatedly for each user, right? For example, things like dashboard or user configuration, user settings. These are kind of things that every user needs as soon as they log in, right? And these are the kind of things that you can easily cache on. And once you cache into memory, right, basically you optimize the performance, and you are also relieving your database from unnecessary repeated work, right? And there's where in memory cache comes in. So some of the things like memcache, Redis, memcache is was made famous by Facebook. So these are the kind of things. This also comes in between, right? Moving to next. Now, if things are so far clear from the database side, even from the web server side, we have all these static contents. Now, what we are trying to do here, we are trying to apply next level of optimization to our applications or to our web application. So all the static content like CSS, JavaScript, raw images. I mean, why all this round trip to your application server or even database, right? So these are like static contents. So these are like well stored in object store kind of a thing, like media files. And your object store can have some logic. So for example, in current modern scenario, uh, whenever you upload a page, whenever you upload an image or a video, um, these images are optimized based on different device types, right? For example, mobile may have a low resolution image, and different image sizes. Even basically whenever you upload a video, basically the size is reduced, all those compression logic, everything, right? So we see a need for a computation whenever something gets uploaded. um, Basically, something needs to happen. Now this is very good case for something called like lambda or Google function, where you just need a trigger for something, some computation to happen based on some event, right? So basically, this we need a function for this. uh, Now let's talk about CDN, right? So again, when I'm like hitting foo.com, um, I am in India, right, and my server is in US, right? And CDN, what it does is basically it co-locates all these, static content very near to me, maybe near some server location in India. And basically, each of these cloud, there is nothing specific to Google Cloud, but basically each of these cloud service providers have their own, CDN networks, and they're also shared, and they can serve content right from somewhere near you, right? And that basically adds additional layer of performance and reliability, right? So CDN cache. um, Now, any modern application, right? I mean, take today's scenario, right? How many notifications have you got? How many emails, messages, alerts, SMSs you have got? And any modern application, right, needs to support that, right? And for this, we definitely need some sort of messaging service. um, and obviously this needs to happen in asynchronous uh, method. Now let's just recollect, this is the big picture. I mean, this is what we see. I mean, most of the applications you would see like this, and I'm trying to take you back to before cloud days, right? Most of the application used to look like this. You can take out that media processing function out, but most of your applications would mostly look like this, right? This is how I grew up in this industry, with these kind of simple applications. um and But there's still one big piece missing than what we saw. um and that is basically analytics. um Analytics basically, what can happen is that your web server is producing a lot of click related data. Batch data is getting generated into your logs. You do a lot of analytics, right? You want to see and monitor how your application is behaving, what are the security threats, right? Things like that, for audit purposes, right? So there's a big piece where basically we do analytics. And data can come in real time or in batch. uh, this data needs to be ingested, it needs to be processed. Processing basically take it to the data warehouse, and from data warehouse you do analysis. Now these are all very fancy words. You would have seen or heard very simple term which we call ETL, right? ETL stands for extract, transform, and load. And what you typically do over here is get ready to process data the way you want to see it for higher level reporting, monitoring, operationalizing, make it more efficient, right? and use these data points to also improve the operability of your app. So this is again 30,000 feet view of what your application looks like. I think what exactly are we missing here? We still are missing monitoring. How are we monitoring this app? We are missing security. We have not talked about security at all. And from pure developers perspective, right? Basically, DevOps, this whole thing, right? Now this is 30,000 feet view of 99% of the applications on this planet. Okay. Um, I've still not talked about microservices architecture, and I have not talked about data lakes yet, because I think that is a separate discussion. But for our current today's discussion, I think this is good enough. So from here, things are going to change rapidly fast. So I want to make sure that each one of you is very comfortable. So thumbs up if you guys are understanding what's happening and where we are going. Any questions so far? Am I audible? All right, thank you. So yeah, one thing, guys, is that let's make this a little more participative. The more we have participation and discussion, I think this is going to be really good for everyone. Let's keep energy levels high. Okay. So now, if now I told in the start, right, that we are trying to play a role of an architect for foo.com, right? Now suppose you are a cloud architect for foo.com, right? How are you going to translate this architecture into Google Cloud, right? And there are so many ways to achieve this, and no one way is right or wrong, but I'll show you one of the ways. But based on your experience or based on who you talk to, different people will apply different logic to this architecture, right? So let's follow what I think should translate from here. Okay. So let's see a couple of slides back. So basically, this whole infrastructure over here, right? Once you take it into the Google Cloud or any cloud, right? First thing you need to do is basically protect it using virtual private cloud. Okay, you need to put your entire infrastructure inside uh, your own VPC, right? Uh, for those who of you don't know what VPC is, basically it's like your own corporate intranet, right? Basically, there's a outside traffic and there's an inside traffic. Basically, you have a concept of subnet and intranet, right? So this is what it boils down to, right? First thing you do is protect yourself, right? And this basically provides managed network functionality for all the cloud resources that we will be talking in the subsequent slides. All right, so if you see on these slides on the left hand side, what we have, let me briefly spend a little bit of time on this side. So what you see over here is that, for networking, these are the Google Cloud artifacts. Okay. So in the major areas of computation, cloud computing in Google, right, you have compute, you have storage, you have databases, you have big data, you have AI ML, right, networking. And this is what we have been talking so far. If you remember from past slides, this is what we have been talking about. Now I'm going to map each of these components, right, how we are going to convert into Google Cloud Architecture. Okay. So web server, right? So web server, basically you need compute nodes, right? So in Google Cloud, you have something called Cloud Run or App Engine, which are basically managed virtual instances. When I say managed, basically if you do Cloud Run, basically you can run these instances. You never have to configure your machines on your own. Basically they'll auto scale. You can just deploy your solution, right? Deploy your code, and basically scalability, patching, all these things will be auto taken care, right? So if you don't want to do a lot of investment on your hiring talent to manage this, basically you have a small team who just wants to focus on pure development and not infrastructure management. Basically you use Cloud Run and App Engine. Google Kubernetes basically helps us deploy containerized applications within Kubernetes without much of a learning curve, and it also offers autopilot for when you need the flexibility and control for limited option engineering. Okay. Now coming to compute engine. So compute engine is as simple as going to the market and buying a hardware for yourself. I mean, there's no management. Basically, you are just doing everything on your own. This provides you maximum control, uh, and there is a state of virtual machine, right? So we can define what type of disk you want, what type of CPU you want, how much memory you want. You want it to be auto scale. All those things basically you can configure when you are defining this computing. Okay. Now same thing needs to happen on the application server. Application server is also basically a compute entity, right? And basically whatever applies to web server also applies to application server, right? So just keep in mind that so far we have used, 5 Google services. You know, One is basically, your networking node basically at the top, and then basically we have used 4 of these compute services, right? So total 5, and the and basically this list is going to grow very fast. Now for load balancer, basically, we basically have other Google services in networking. So cloud load balancing, this is basically offered by Google Cloud, and this basically what it means is that basically this Google Cloud this cloud load balancing is basically for the outside load balancing, right? So this be something called Google front end interface, and what it does is that it has built-in feature that the way it does cloud load balancing is that it tries to get users and requests from the same geolocation. For example, if I am from India, right, it'll try to serve request from the servers that is nearest to the India if I have configured my infrastructure like that, right? And similarly, basically for internal load balancing also we can use Google Cloud load balancing. Okay, and these are part of Google network. Now coming to the CDN, right? Basically cloud, this can, again, you can use Google Cloud CDN to cache the frequently requested media and web content closer to the user at the nearest edge location. Okay. Similarly, for object store, to store the media, we can use something called cloud storage. And just by convention, basically, guys, if you see the icon on a text, it means it's a Google Cloud service. Some of these, we are going to cover. It's not possible for us to cover each and every service in today's short session, but this lay of the land needs to be very clear. And during the demo, I'm definitely going to touch upon some of these services. Okay. DNS server, basically Google again provides cloud DNS, right? For this, uh, and basically cloud DNS is Google's infrastructure for high volume authoritative DNS serving, which offers 100% SLA, means that it never goes down, right? Google never goes down. Uh, Guys, so far so good. Thumbs ups. Any questions so far?
Naveen, there is one question
Yeah, yeah.
in the chat box. The question is from Hanid. This web server is like a Nginx reverse proxy something.
Yeah, so basically, see, web server, basically you can think of it like, Apache or IIS. Uh, Nginx a version can do that, but Nginx reverse proxy actually does a lot more than a simple web server. Is that clear?
I think we can move ahead.
Yeah. All right. Thanks. All right. So cloud functions. So basically, we said we need media processing, right? So for that, we need Lambda or Google Cloud Functions. So this is something that we have built into Google Cloud. Um, moving on. So remember, basically we talked about notifications and email, SMSs and that kind of service. So for that, we have something called Google Cloud Pub Sub. Um, and basically it is a asynchronous service that can consume events from application server or any other data source, and you can configure it to do notifications like email, SMS, or push notifications. All right, now coming to the database. As we talked, we have relational database and non-relational database. I mean, the services that are offered by Google Cloud. And again, I keep using this term that, I've seen most of these, cloud services. I mean, there are parallel services, that parallel services that are provided by both of them. I mean, you have relational database parallels in AWS world, Azure world, and Google Cloud world. That's why I want to keep it a little generic. There's nothing very specific to Google Cloud. I'm using the Google Cloud components and services, but at the notional level, you just need to understand these services are available by everyone. Okay, but very specific to Google Cloud, you have Cloud SQL and Cloud Spanner. Okay, uh, Cloud SQL, basically if you need MySQL or Postgres or a SQL server, and again Cloud SQL is managed, so you just basically use this service to spawn a MySQL server or a Postgres server, right? Cloud Spanner basically is best known for massive scale relational database, uh, and it basically fulfills the requirement of infinite horizontal scaling. By massive, I mean like thousands of writes per second and tens of thousands of reads per second, right? And that can scale globally. So you can just spawn one of this, very expensive though, but once you spawn it, you don't need to bother about availability, scalability, performance, right throughput, all those things. Okay. uh, Also remember that most of the services that you know that I have mentioned so far, right, um, it's not like these have just come into existence. Most of the Google Cloud services that we consume on a day-to-day basis, right, they actually use these services. uh, so YouTube, I mean, if you take top 10 Google services, uh, which have like billion plus users, right, um, most of them use these services actually, right? And there's a very interesting read. I can share a link later, but many of these services basically have come out of those requirements where basically it had YouTube had to work at that scale, and you know Android and Chrome had to work at that scale, and that's why we have these things, right? uh, Google search engine itself, right, uses many of these for indexing and that kind of storage level. um, Similarly for just a minute. So for relational database, basically we have Cloud SQL and Cloud Spanner, and for non-relational database, basically we have Cloud Firestore, Cloud Bigtable, and Cloud Memory Store. Now, Bigtable is something that famously is used by Google search engine itself for World Wide Web indexing. It's a very simple, hash table based key value pair uh, linear table, and basically, scales infinitely. Okay. Um, Firebase is a serverless, document database that can be used as a service. It's very easy to set up fast results, complex queries in real time. Okay. Uh, Memory store is just a minute. So memory store basically is a fully managed in-memory data storage. So we talked about memcache, we talked about Redis and these kind of services where basically, you need to cache a lot of data inside your inside memory. Basically, both of these cloud memory over here and cloud memory store over here, they both are replaced now. Okay, so basically this is in-memory database, right? And these are very great for web and mobile, where you really need performance, and 2 second 3 second of delays generally even not acceptable in today's modern infra. Now having we have covered the OL TP part. Now OLAP, basically how does Google Cloud fit in here? Okay, so data flow can be used for processing and enriching. Data analytics with Cloud PubSub or Cloud Storage, BigQuery, Data Flow, Data Proc, Looker. I mean, these are some of the Google Cloud components that we are going to utilize in data analytics and processing. Okay. All right. So let's get started. For ingest, we again have Cloud Pub and Sub, which is we have already mentioned it. Cloud storage is something that you store digital data, right? This is and we use it for storing logs. This is the place where we are trying to consume data for processing, right? So it could be subscription based, event based from web servers, or it could be click stream or things like that. That is basically pushing data into your ingest layer. And basically we use Cloud PubSub and Cloud Storage to ingest all that data and send it for processing, right? Now, what do we use for processing, right? So Cloud Data Flow and Cloud Data Prep, these are the two services that we can configure to basically process the streaming data or static data or batch data. And to basically process that, based on that, we send it to data warehouse. Now BigQuery is basically your data warehouse solution for Google Cloud. When I talk about BigQuery, it's a serverless data warehouse that supports SQL query that can scale to petabytes of data, right? It can also act as your long-term storage and a data lake. We have not talked about data lake, but as a solution, basically BigQuery can also be used for data lake purposes. We can run SQL queries to analyze our data within BigQuery, and literally queries over petabyte of data and response within seconds. I mean, this is very fast. And from the analysis part, basically you have Looker, you have Data Studio. You want to visualize this data. You want to create visualization data. You want to create a dashboard for your boss. I mean, this is the area that we need to work on. And this layer also basically borders around doing AI and ML based on the data that you create. I mean, in 21st century, basically all the companies are data companies now. Effectively, data is gold, and all this data that you collect, basically you can do AI and ML to further improve your user experience, performance, stuff like that, right? So all online recommendations that you see, food recommendations that you see, basically it's all data that is being collected, crunched, right, on the cloud. And basically BigQuery, under BigQuery, analyzed, and basically next time you go to the Google and you search for something that you search for, and next time you start seeing those ads, right? So don't be surprised, this all is happening over there. Okay. So AI and ML, how does that connect to the Google Cloud, right? Basically AI ML is all about data, right? You have an app creates data, it creates lot of data based on user. You basically capture all these things, right, and you feed it into Google Cloud, and you have something called Vertex AI, And Google basically has a lot of pre-trained models. Like for example, you already know voice recognition is there, right? Not only cloud. Basically, you have services for voice recognition, text to speech, right? Speech to text, right? Video to text. All these services are already there. Image recognition, right? All these are pre-trained and available to use. But in case you don't have these, um, basically in that scenario, you can feed all this data into AutoML. So AutoML supports all your common use cases, uh, and basically you can do this in-house, and framework of your choice. Basically TensorFlow, you can use PyTorch, you can choose any one of these to model your data and feed into Google Cloud. So that kind of covers a lot of area. Um, we are still to do with monitoring, security, and DevOps, and how these typically fit into our show. Um, any further questions, guys? If we are all good, if we have understood so far, I understand that I've thrown a lot of components in front of you. Don't be bothered about it. Just remember the original blueprint that I gave. These are just trying to fit in wherever they're applicable, right? But just remember your base template, right? Where all these cogs are coming and fitting. Hope all these things is making sense to you. Thumbs up, please, if all okay. Otherwise, questions. Thumbs up if you can move forward. All right. So let's quickly move to monitoring. We need to move a little faster because I had set up like 40 minutes for this and 40 minutes for like hands-on drive. We are already all 37, so we'll try to move a little fast, right? So in terms of operational suite, and this is kind of trivial now because this is all log processing, operational data processing. So we have services like cloud logging, cloud monitoring, error reporting, cloud profile, and cloud trace. I mean, all these things are doing is collecting data from logs, collecting data from user clicks, stuff like that, operationalizing things, right? Monitoring about errors, outages, stuff like that's all monitoring, right? But it is I'm not trying to trivialize it. It's very important, one of the most important functions in any application, right? DevOps, basically ops comes, this ops part of the DevOps, right? So it's very important. These are the tools that you use. Security, again, very important, and I'm going to cover some of this in hands-on demo. Um, so in terms of security, I'm just going to show the components that form Google Cloud ecosystem of security. Um, so confidential computing, and I'm going to very quickly run through these. So confidential computing is basically if you need some computation where you need high confidentiality, right? Basically, it is going to encrypt data during processing, right? You cannot even see, even in memory, it's all encrypted, right? And that processing can happen, right? This for highly confidential data, right? You have cloud KMS. KMS, basically, you can have external key managers, right? You can manage your own keys. Google can manage keys for you, or you can bring your own keys, or you can have hardware security model, like HSM, and basically, um, so basically, how do you make sure that your applications are secure, right? For application like foo.com that we just took about, basically it's an internet facing application. You also have captcha services and cloud armor, right? So reCAPTCHA Enterprise deciphers the token in the incoming request from the user, and then enforcer allows or denies the decisions in the cloud armor. So this is where it kind of fits in. Cloud identity and cloud IAM, basically cloud identity is I am who I am, right? Basically, that's what cloud identity is, trying to make sure. Cloud IAM, basically identity and access management, basically if I am me, what I can do, right? So that's what IAM is. So Coming quickly to DevOps, basically when I talk about when I talk about DevOps, right, how does CI/CD kind of fit into Google Cloud model, right? So you have the components that we'll talk about in this ecosystem is basically cloud build, cloud code, cloud deploy, binary authorization, artifact registry, and more, right? Um, so as a developer, right, there's a use case, right? I would write code for an application. I can use cloud code um, within IDE to push the code uh, I'll push the code to cloud build, which cloud build will basically package and test it, and then basically test it for vulnerability, scan it, binary authorization, then checks for trusted images. And once all this thing is done, right, basically it can be deployed to staging using the cloud deploy, right? So next slide, I think will make it a little clear. From here, I mean, as a DevOps person, you can create a process to review and promote the application to production. In case of containers, um, containers basically images are stored in artifact registry. This is what artifact registry is used for. And from here, actually, these can be deployed to Google Kubernetes Engine or Cloud Run. And I think if you have stuck here so far, so congratulations. What we have discussed so far, basically, we call in our ecosystem, we call it universal architecture language. And this is what we use in Google lingo. All the components with all their areas, and this is still not exhaustive. Basically, I have just put like top 3 or 4 uh, products and services per operational area. These are like top 40 or 50 services that are there. There are a lot more options for more specialized use cases, but this is what we have covered so far. Okay, I'll give you the link at the end of the session. So this is a link that you all should be able to click and use. um, I'll share this link with you guys. All clear so far? If everything is good, we can move to next session. Thumbs up. Cheers. Hey, Ashutosh, do you want to take like 5 minutes of break right now, or shall we just continue? What do you suggest? Ashutosh is there? Hello.
Naveen, I think we can take a 2 minutes break.
All right. So we shall all be back by what, 3:55 maybe, or 4, whatever it works for you, or we shall be back by 4 o'clock.
Naveen, 3:55 should be okay. We can take a quick break. No
Sure. All
worries.
right. Thank you.
Right.
Be right back.
Everybody just
Thank you,
grab
Kuncha.
a cup of.
Sorry, Naveen. I was just around. Thanks, Kuncha.
No
3:50.
problem, Ashu. Ashu, we just announced a 3 to 4 minutes break and we will resume at 3:55. I hope that's okay.
Sure, I'll request participants not to log off. Just, mute, be around. In the meanwhile, I'd like the participants to know that if you stick till the end, you would be getting a Amazon voucher. The Amazon voucher is very easy to earn. It's 1,000 rupees Amazon voucher. Stick till the end to get the Amazon voucher, 1,000 rupees each.
Okay. Hello guys, I'm back. All right, so we'll get started. And Indra, I read your message that be sharing recording with us. Ashutosh, can you please respond to this?
Yes, sure.
Okay.
Just yeah, Ravi, 1 minute. Yeah, sorry, Naveen, can you repeat the question?
Yeah, basically, we are recording this session, and this session is going to be available, right?
Yes, the session is going to be available on edForce website at the edTalk page.
Okay.
Anything else?
That's it.
We may resume the session, right?
Yeah. All right. So, um, um, just a minute, guys. Let me share my screen. All right. Is everyone able to see my screen? Thumbs up if yes. Okay. So, guys, Control A, C. I'm going to share a link with all of you. So when we talk about Google Cloud services, right? How do you? There are primarily three ways to access cloud services. First is what we call as Google Cloud Console itself, um, and I've shared the link with you. If you can click that link, it will take you to cloud.google.com. And how many of you already have tried Google Cloud? I mean, based on that, you may already have an account and it may directly take you to the console directly. Otherwise, if you have not, uh, basically, you'll see, sign up kind of a thing. Otherwise, what you should actually see is console here. Okay. So depending upon where you are, I mean, you can try signing up. Um, Basically, when you sign up, you get $300 of credit, where you can try cloud services, Google Cloud services for free. Um, but based on it may take some time, because sign up also requires you to enter up uh, your billing details for billing purposes. I mean, though it will not immediately start charging you up, but that thing is required for billing purposes. Okay. um, as long as you're in the free tier, you are not charged. But if you are able to successfully log into console, right, um, you may start seeing um, a UI like this. Okay. So this is the landing page for any Google Cloud project. um, so let me just explain what a project is. So project basically is a notional is a virtual entity under which you create all your resources. So if you look at the hierarchy, you have organization. Under organization, you can have multiple projects, and each of the projects can have these compute nodes, these databases. So it is just a logical organization, and it is also useful to control the access. You may restrict access of one project resources based on that project, and either you can share these resources among the projects or you can restrict it, right? So that's what it is used for. Now, once you come to this view, you basically will be also shown what resources you are using. So I'm just going to give you a walkthrough of this, a very quick walkthrough of this concept. Okay. Um, uh, Status, billing, monitoring, all the APIs that we use, what all resources are you have created for this project, all these things there. Now, one of the most important thing in this dashboard is basically this hamburger button over here. So if you click on this, you see a lot of services that are listed over here. For this specific project, I have used Compute Engine, I have used Kubernetes Engine, I have used Cloud Storage, I use BigQuery, Cloud Run, SQL, stuff like that, logging, all these things are here. Okay. So this is just from the navigational perspective. If you come to Compute Engine, so basically, if you can create you can create an instance here. A compute engine is basically like a virtual instance. It's a machine. Let us just create one. Um, you have to give a name. You have to select which region and zone it belongs to. Is it a general purpose, uh, compute optimized, memory optimized, storage optimized, GPUs, right? All these options are there. We are going to go with very basic one. You can choose the machine type. You can choose pre-built machine types, and these are a lot of options. So it may look very complicated to you guys, but think of the hindsight. If you are going to buy a laptop or even a mobile, what are you actually seeing, right? You're seeing how much RAM it is and what kind of peripherals it has, right? What's the storage? So you're looking for CPU, you're looking for memory, you're looking for hard disk, right? More or less, this is what you're doing with much more fine tuning to the server level. But if you just want to create an instance with basic defaults, that's good enough, right? And it will just create it for you, right? You just do create, make sure all fields are completed. Just a minute. Advanced E2 instances require spot provisioning. Just a minute. Create an instance. So sometimes that can also happen. So right now it will take some time to spin, but within some time it should be available. I have already pre-created instance for you. Thing to note over here is that basically, whenever you have an instance, you use it during your free billing cycles. You play with it, but don't keep it up and running because it consumes your free quota, right? It is built. And there was an instance where I forgot, I created an instance, I kept it running and I left it. And at the end of the month, I got a bill for 10,000 rupees, right? They were nice enough to understand that it was an honest mistake and they kind of refunded it. But keep it in mind, use resources, create resources, play around as much as you want, but make sure that you delete those. Okay. Now, as soon as this instance is created, basically you have two IPs that are available. One is the internal IP and one is external IP, right? external IP is something that you can use to connect from the external one. So let me just check one setting here. Um, enable connections to the same port. Allow HTTP, allow HTTPS traffic. So you also need to set up your HTTP settings if you want to do a web server. Basically, you want clients to be able to connect, customers to be able to connect via HTTP, right? So these are all the settings that you could use. Okay. Now to connect to this, right? Um, so to connect to this, basically you can do SSH here. And basically all those SSH handshake happens, and you should be able to able to talk to this VM. Authorize, and boom, you are connected to this thing. Okay, ls-l pwd, right? So this instance is available to you. You can install Apache. I mean, it's as simple as working with any Linux. And you remember I told it's so easy to get an instance right now. When I started in 2000 to get a Linux instance provision at Oracle used to take 3 to 4 months, and this simple thing, boom, that happened in 10 minutes, right? So this is what I was talking about. When I mean, today we may not realize where we are, but we have seen those days as well, right? So this is the instance that is available. But apart from this, right, what I also want to explore is, this is bare metal, right? Basically, you get a machine, you do whatever you want to do. You want to use it as a web server, you want to use it as a database server, you want to use it as an application server. It's up to you, right? Everything needs to be done by you. This will be managed by you. This will be scaled by you. This will be secured by you. This will be patched by you, right? All the infrastructure related maintenance requirement, everything has to be done by you. But if you are someone who just needs to has a small team and is just interested in development and basically all this infra thing, right, you want Google to take care, then basically Cloud Run is something that you need to go for. Okay, now given that we have so many services over here, we have this search box, which is very convenient uh, for us to be able to search for things. So for example, let's say app engine, right? App engine. So immediately you'll read that app engine is basically a managed app platform. Okay. If I click on this, your app engine has been created. Get started. So you see here, what it's trying to do is that you can create an app engine for whatever language you want, right? You want Java, you want Python, you want JS, all these things. So remember, when we use compute engine, you got to even install Apache. You got to install everything that you need to use, right? When you use app engine, basically all these runtimes will be available for you. You just need to deploy your code and start working on it. Okay, so these are pre-built. They will auto scale, right? They will patch, they will do maintenance. You just need to work with your code. So that is the thing. Few options, flexible and all this, right? So that's the basic difference between an app engine and a compute engine. There's one question, one very common question that gets asked. Okay. uh, Now looking at we'll start looking at some of the databases. Just a minute. So let's again come here. Okay. So under compute, you have compute engine, you have, all these things. Uh, Under storage and database, right? So basically, you have cloud storage, you have Firestore, you have, these are basically for storing media files and those kind of use cases. You have analytics, basically you have BigQuery, PubSub, Dataflow. Now these are the blocks that we talked about in our original architectural layout that we did. Okay. Um, Networking we have covered, distributed cloud we have covered, serverless. So in databases, right? Basically, uh, there are two kinds we talked about. We talked about relational database, and we also talked about non-relational database. So for example, if you want something managed, right, you want something to auto scale. You don't want to have a virtual instance and install all the databases on top of it, right? If you want pre-packaged ones, then basically you can use something called SQL, right? um, so basically, this is very user friendly, and whenever you uh, try something new, basically it'll also give you nice steps to get started, and you'll also have an intro video kind of a thing, because this is the first time, like, from this account I'm using it, right? So create instance. So as I was telling, that basically if you use this SQL of cloud SQL option, right? So it will ask you whether you want MySQL, PostgreSQL, or SQL Server, right? And I'm not going to click any of these, but basically if you click, basically it will create a auto scalable instances for you, right? And you can use it. Now let's look at, just a minute. So that's the SQL. Now spanner is something that we covered. uh, Big table is something that we covered. So it kind of follows the same pattern. You click on any of this, it will allow you to create uh, you know uh, create instances, um, and it will ask you some basic information. And each of these services, it's a common pattern. Is basically you fill all these things, but also keep note of the pricing estimates, right? uh, so BigQuery is something that I told you is highly scalable, and it is all, this is basically worst case scenarios, but this obviously for a huge age. So this is what is coming up to, right? um, all right. So storage, basically file store. So for you to store your media or static content like that, basically, uh, just a minute. So I'll just quickly show you the BigQuery part. So BigQuery, as I told you, basically, you collect all the application data, and basically you can stream it to the BigQuery. BigQuery is highly scalable, and you can all the telemetry data from your application, logs, all those things you can get collected, and you can do AI and ML on top of this, right? So you can write your own queries here. You can create materialized views. So this is basically database part of it. Guys, all clear so far? So one thing is that I'm not going deep into each of these services because there are two. Because what I've tried to do is showed you the virtual instance, right? Create it. I've showed you a couple of databases, but we also will have to explore these further. But I'm just showing you the pattern of how to create these and be able to access this. The pattern remains the same, right? Ankit, not seeing your Linux machine. Is that resolved? All right. I see that Surabhi has raised hands. Any questions, guys? So far? Hello. Am I audible?
Yes. Naveen, I think the participants are mentioning about the Linux machine that they are not able to see. Could you just reshare your screen and show it once to them, if that's possible?
Um, is that a separate screen that I need to share, or?
No. Right now, I can see the Google Cloud Console. Is that
Hmm?
what we are referring to?
Yeah, that's what we are here right now.
I can see it then. Akshay and Aniket, can you confirm? He is on the Google Cloud Console screen.
Hmm.
Okay.
So basically,
Naveen, they are
right
saying
now,
they can.
right now I'm on the project dashboard.
Yes, I can see that.
Yeah.
Okay, Aniket and Akshay, if you have a question around, the machine or the console, you could just paste it in the chat window and Naveen could answer it for you.
Okay. Any more further questions? Are we good to continue?
Yes, Naveen, we can.
Okay. So I'm going to show you one of the projects that it's a test project that I was working on. Um, just give me a minute. Looks like my account has some billing issues. Um, To avoid losing access to Google Cloud Service, an administrator must verify this account. Just a minute. I'm stopping sharing for a minute, guys.
In the meanwhile, Surbi, you have raised your hand. Do you want to say something? Your mic is muted. Surbi?
Uh, no, Ashu, actually, it was by mistake.
Okay, great. Madhura, your hand is also raised. Do you want to say something? Your mic is muted. Madhura, you want to add something? I think Madhura doesn't want to add anything. Madhura, we can't hear you even if you are trying to add something. Last, I think Ashok also has something to say. Ashok, do you want to add something? Your mic is muted. If you want to add something, please. Okay, I think they must have by mistake raised their hands. Great. You may continue, Naveen.
Yeah, sure. I need to actually re-verify my account billing thing. So just give me a minute, guys. It's not allowing me to move forward.
Do you need to be aware of that? So in the meanwhile, guys,
Yeah,
I,
just a minute, guys. It'll take a minute.
yeah, in the meanwhile, I'll explain you what to do and how to do to win that Amazon voucher. Okay. Are you guys ready? If you are ready, please show me a thumbs up. Any thumbs up? Oh wow, there are a lot of people who are waiting to win the Amazon voucher, it seems. Great. Let me share my screen, show you how to do the same. Share. Great. So on Google, you need to go and type edForce, not the website, just edForce. You would see edForce here, and all you got to do is write a review. Maybe take a screenshot from this edTalk, add that screenshot to write a review. How did you find edForce as a training company? If you have had a past experience, how is it going for you? Take a screenshot, follow us on our social media. All the details will be there in the email. All the screenshots once mailed, it will take 10 working days for me to share your Amazon vouchers. So be ready. Email will come to your systems tomorrow. Be ready to grab your Amazon vouchers. Isn't that great? If it's okay with all of you, please give a thumbs up. That'll just help me.
Ashutosh, I'm ready.
Great. Take over, please.
Okay. Um, all right, guys. Are you guys able to see my screen? Okay.
Yes, we are.
So one thing we talked about is in Google Cloud offering, and there's a very quick way to start, right? A full-fledged web or mobile application ready development. So, for example, what you need to do is I'll just share this link with you guys. Um, um, there's something that you can use to just spin off a project. Obviously, you need to have a Google account for this. But once you do this, you add a project. I can name a project my first mobile app. And since this name needs to be unique, basically it is going to add some random thing over here. So which is fine. I'll just take the default. I'll continue. Choose or create a Google Analytics account. Let me just create a project. And it is trying to spin. It will take a minute or two. So meanwhile it is finishing up, let me just tell you what's happening here. So basically it has created a ready to use Firebase project for me. I can directly go to this project, and what it is doing is you can directly use it for app hosting, right? Agree. You can use for connecting it to database. So what is Firebase? Basically, Firebase is a out-of-box database that is available for you. It's a NoSQL like MySQL, right? It's a NoSQL database. If you look at project overview, it provides basically cloud firestore, it provides authentication, it provides storage, and it provides hosting. Very ideal for a mobile app or a simple web application which requires a database support. This is all it took, right? For example, if I go to its firestore, obviously first time if you do, you'll have to set it up. So it has a lot of this uh, getting started documentation, and there's a regular flavor. Anything you start, you'll get a lot of documentation, you'll get videos. So basically all the tutorials and everything are like built in. It's very user friendly. And in that basically you have all these functions, storage and hosting features available, right? Now if I click on Firestore database, it the first thing it asks you to create a database, right? You can click on this database ID. This is your first database. Your default cloud storage will be also set to location. Next, start in production mode, start in test mode. So difference between the production mode and test mode is in production mode, basically write and reads are not allowed by default based on the auth that you provide. But just to play around with it, right, we'll start it in test mode. Create. And the database gets created, right? You can start a collection here. Collection is basically a table for you. It could be, user. Next, what are the fields required? Auto ID field, name, email, auto ID. You just need to create one document. Naveen d@c.com. Save. And basically you have user table with one record with one user. So this is a database, right? What you can also do over here is you can opt for authentication. You can set up authentication, how your users need to be authenticated. Again, you can get started. And you see all this built-in, it'll have a user set up sign up methods. You can do all this email, phone, anonymous, all this built in. You just need to use auth APIs, right? So first, way of accessing Google Cloud was the Google Console, the dashboard that we are currently using. Second is basically you can use command line shell Google Cloud. Third one is using the APIs, right? So Google API will provide you with all these JavaScript libraries or Node libraries or all these Python scripts and all these things to be able to connect to these APIs for auth, APIs for storage, API for database, API for auto scale. All these APIs are there. API for Google, right? All these Google services are provided to you through APIs. Okay. Uh, then there are basically these templates, all these things. So basically what we did is once you create a Firebase project, uh, you get database automatically, you get storage automatically, you get all these auth services automatically. All you need to do is basically, write a piece of code which basically generates HTML and you just deploy it over here. And if I could show you some of the existing projects that I did, if you look over here, I have set it up for authentication. My sign up method is basically phone. Firestore database that I'm using is basically has all these tables. And hosting, basically I'm doing this hosting here, and all these URLs are there. I can just click on this and these URLs are publicly available. You see this, and this is just so easy, right? Storage, what I'm doing in the storage is storing all these media files related to properties, all these images and videos and stuff like that, right? And these are all API calls, right? So this kind of gives you an overview of how applications are deployed, what Google Cloud is, how to turn up instances, how to deploy your applications and stuff like that, right? So this is all I could cover. If you have any questions so far, let me know. Otherwise, we are ready to conclude this journey. Are we good? All right, Ashutosh, the table is yours.
So I do see two questions. I hope they have been answered. Have they been? So in the question and answer section, there's a question from an anonymous attendee. Do I need to be aware of all these components and select one by one, or Google has a recommendation wherein the list of components needed for a specific kind of application are already defined?
Sure. Okay. So I see the question. Sorry, guys. So yeah, basically, see, there are a lot of components, but no one hardly expects you to know all of these. Okay, it all depends upon. See, it's like mobile, right? Mobile has a lot of features, right? Doesn't mean that you use all these features. Basically, call features and all these things. So there are some common ones that you really need to know. So even from certification perspective, right? If you're going for a Google Cloud engineer or Google Cloud developer, they need you to know 20, 30 common ones. 4 or 5 of them I've tried to cover today, but not all of them, because most of them are very specific, very specialized, right? But you do need to know some common ones, right? And for each one of them, like for example, you have compute, you have storage, you have database. So you need to know 2 3 common ones in databases. You need to know 2 3 common ones in compute, networking, like that. So yeah, big answer, short. Basically, you don't need to know everything, and nobody knows actually, right?
Okay, great.
But if you are an architect, right, the more you know, right, the more it helps you in solutioning perspective, because with the customers you can negotiate that this is good, this is better, this is best, this is not good. Some of these will not fit into certain scenarios, some of these will fit into certain scenarios, right? So knowing as many components as possible is good from architect perspective. But if you're coming from a developer perspective, you just need to know what you need to know. Okay.
Great. The second question looks like a lot of components. This will take a good amount of time to know details of these components for any user. I think you have answered this already.
So I'll try to again answer. I know this problem because I have I have come from being a developer, to a team lead, to a manager, to an architect, right? I have played all these roles, right? I've seen this entire spectrum in 24 years, right? That's why basically the way I started my presentation, and many times people start getting confused, why we do this. But the architectural paradigm that I showed in front of you without using any components, right? That is something that you need to have in your mind. Now that gives you a Google map or a compass kind of a thing to navigate yourself around any land of lay of cloud, be it Google Cloud, be it this. Everyone needs to have a database. Everyone needs to have a storage. Everyone needs to have a network. It's cloud. It's not this cloud, right? It's real infra cloud, right? And you need to be able to map that. So this is one thing you need to take away from this. That's why I started from there, and that's why I started pulling up those components. Hope that answers.
Great. I think that does. So thank you, Naveen, for helping us understand.
Thank you very much.
Just a second. Ladies and gentlemen, as we come to the end of this insightful ED Talk, I want to extend a heartfelt thank you to each and every one of you for joining us today. Your participation and engagement have made this session truly special. A special thanks to our esteemed speakers. May I see a few applause and emojis, please?
Thank
Naveen,
you.
for sharing his wealth of knowledge and expertise on Google Cloud Platform. Naveen, your insights on setting up GCP, navigating the console, and understanding key services like compute engine and cloud storage are invaluable. The practical strategies and the real world use cases you provided have certainly given us a clearer path to leveraging GCP in our own environments. I hope everyone found the session as enlightening as I did. Remember, the knowledge you have gained today is just the beginning. By applying these insights, you will truly transform your approach to cloud computing and drive significant value in your organization. And now, the moment you all have been waiting for, the announcement for Amazon voucher. If you stay with us, if you have stayed with us till the end, keep an eye for your email for rupees 1000 voucher winning strategy. Congratulations in advance, as the vouchers are for all on completing the task. Before we wrap up, I would like to remind you about our upcoming training session on Google Cloud Fundamentals on the 1st and the 2nd of August. As attendees of edTalks, you are eligible for an exclusive discount, a massive slash down price. Don't miss the opportunity for further enhance your cloud skills. Once again, thank you all for being here. We look forward to seeing you at our next edTalk, where we delve into the world of technology. Have a great day ahead and keep learning and innovating.
Thank you, Ashutosh. Thank you everyone for joining.